Welcome to The Explainer. Look, for decades we've just accepted the standard model of how reality started, right? But honestly, the cracks in that foundation are really starting to show. Today, we're setting the stage for an investigation into the ultimate cosmic mystery, our origins. We're going to explore the Big Bang paradox and why literally everything we thought we knew about the start of time might need a massive rewrite.
Okay, let's dive into this. It is arguably the most mind-bending question you can possibly ask. What came before the beginning of everything? I mean, we've all been taught that the universe started completely from scratch about 13.8 billion years ago, but recent discoveries in some wildly new theoretical physics are forcing cosmologists to ask, what if that beginning wasn't actually a beginning at all, but rather a transition? To really understand why scientists are rethinking our origins, we kind of have to look at the massive, glaring flaw in our current model, and that is the Big Bang singularity. By definition, this is that terrifying point of infinite density, where all our known laws of physics just completely break down. And here is the ultimate paradox. When you actually sit down and try to calculate the physics of a singularity, the math just stops working. It throws out infinities. And let me tell you, infinities are a physicist's absolute worst nightmare. It forces reality into a mathematical dead end, and it serves as a giant red flag telling us that our model is incomplete.
And that leads us to a real conceptual gut punch. The Big Bang as we know it might just be a paradox. It's a super unsettling thought, isn't it? Framing our most accepted foundational truth as something that is literally unraveling right now. And the crazy thing is, it's not just the abstract math of the singularity causing these problems, it's what we are actually observing when we point our most advanced instruments up at the night sky.
Now, what's really interesting about this slide is how these recent anomalies are acting as cosmic clues. And frankly, they are causing borderline panic in modern cosmology. First, in a 2024 paper, the James Webb Space Telescope spotted this galaxy, JWST 14-0, and it formed way too fast for the early universe. Second, we have these colossal structures called the Big Ring and the Giant Arc. They are so incredibly massive they simply shouldn't exist according to our standard timeline. No way! And third, recent results from DESI suggest dark energy might actually be changing over time, which directly contradicts the constant models we've relied on for decades. Let's just focus on that first clue for a second. I really want to emphasize this number, 14. This is the extreme redshift of that early James Webb galaxy. In astronomical terms, a redshift of 14 means we are looking at something with an impossibly ancient age. Under the traditional timeline, a galaxy of this sheer scale simply did not have enough time to pull itself together. It's literally the cosmic equivalent of digging in the dirt and finding a fully built skyscraper sitting in the middle of the Stone Age. It is just too big, and it is way too early.
So, here's where we are. We have a heavily flawed standard model, a one-time event starting from a single point of infinite density, and it's just breaking under the weight of new evidence. To fix this, theoretical physicists are actively developing alternative, completely mind-bending models. Their goal? To bypass the whole singularity problem entirely and explain the exact cosmic anomalies we just looked at. So let's examine the primed theoretical suspects.
And this brilliantly illustrates our first major suspect, eternal inflation. Detailed in Alan Guth's 2007 paper, this shifts our perspective entirely. It describes our universe not as the whole of reality, but merely as one expanding bubble in an eternally inflating multiverse. Think about that for a second. In this scenario, the Big Bang wasn't the origin of everything everywhere. It was just the local moment our specific bubble stopped rapidly inflating and started a slower expansion. Meanwhile, the vast space all around us, it just keeps inflating forever, spawning countless other universe bubbles. But hey, if you think a multiverse is strange, consider this question for a moment. What if our universe is just a hologram? Yeah, I know, it sounds like total science fiction. But it is actually one of the most rigorously mathematically supported theoretical frameworks we have that attempts to solve the paradoxes of the early universe. Let me walk you through how physicists arrive at this using Juan Maldasena's 1998 ADS-CFT correspondence. Okay, step 1. Imagine that all the quantum information required to describe reality is encoded on a distant, two-dimensional boundary, sort of like that flat 2D security sticker in your credit card that somehow holds a 3D image. Step 2. Gravity and the physical laws project inward from that 2D surface. And step 3, our entire three-dimensional reality is experienced simply as a hologram generated from that boundary data. By dropping a dimension, the impossible infinity-generating math of the Big Bang singularity suddenly becomes manageable. It becomes solvable. Wow, okay. It's a dizzying concept to wrap your head around, for sure. But let's take a breath, slow down a bit, And look at a deeply poetic alternative. What if the universe doesn't just expand, but breathes? This metaphorical idea brings us out of the realm of holographies and right into the fascinating concept of cyclic cosmological models. Let's move to and see how this builds a totally different picture. Unlike the standard Big Bang, with its single, definite beginning creating everything from absolutely nothing, cyclic models offer a completely different narrative. Take the Big Bounce, which was championed in Steinhardt and Turek's 2002 work. This model argues that our current expanding universe is actually just a rebound. It's the result of a previous universe that contracted, compressed, and bounced back outward. Let's actually guide that out on a timeline. Go back minus 14 billion years, and you have a previous universe contracting, pulling all its matter closer and closer together. Then, at 0 seconds, it doesn't crush into some infinitely dense singularity. Instead, quantum forces basically cause it to rebound. The big bounce occurs. Then, moving forward to plus 13.8 billion years, well, we get our current expanding universe. It's such an elegant solution because it completely eliminates the need for a beginning singularity. There was no beginning, just a continuous, eternal cosmic heartbeat.
Taking this cyclic concept even further is Nobel laureate Roger Penrose. As defined here, his 2013 theory is conformal cyclic cosmology, or CCC for short. Penrose proposes a universe that infinitely cycles through successive eras, which he terms aeons. But unlike the Big Bounce, Penrose's universe doesn't crunch back together. Instead, it expands and expands until it becomes completely empty and massless. At that point, it loses all sense of time and scale, which mathematically allows it to smoothly transition into becoming the Big Bang of the very next aeon. It's wild.
So the crucial point is, can we actually prove any of this? Well, in 2013, Ghazadian and Penrose actually searched the cosmic microwave background, which is the oldest light in our universe, and they found these concentric, low-variance circles. Think of them exactly like ripples left in a pond after a stone is thrown. Penrose argues that these are physical echoes of supermassive black hole collisions from a previous eon that actually bled through into our current universe. It's a stunning piece of potential physical evidence suggesting our universe is just one in an endless cycle.
And, this mystery extends right down to the very fabric of the cosmos itself. As Richard Liu poses in his 2025 paper on temporal singularities, are dark matter and dark energy omnipresent? Liu's work questions literally everything we accept as cosmic law. He suggests that if dark energy and dark matter aren't constants across time, then the conditions near the purported Big Bang might have operated on a set of physics we haven't even dreamed of yet.
So, bringing it all together, piecing together the JWST anomalies, the holographic math, and the cyclic echoes, we arrive at this pretty firm verdict. The singularity is no longer the only answer. The traditional story of the Big Bang is officially open for debate. The universe is far more dynamic, and potentially far more ancient than just a simple explosion from a single point.
Which leaves us with a lingering thought to carry with us today. If the universe has no true beginning, what does that mean for our end? Are we destined to bounce, to inflate endlessly, or to just fade into a new aeon? Exploring these source materials really shows us that the cosmos still has some profoundly deep secrets to share. Thank you so much for joining me for this Explainers, and as always, keep questioning everything.